Hello, welcome to another class. We are still on past questions for the Jambite. So today we'll be dealing with these two questions, and this is from the topic electricity. So let's just use these two questions to start with electricity. So we have two questions on the board. This is the question number one, okay, and in this question number one, we are being given this diagram of the connections of resistors. And then the question is the total resistance at PQ, that's at PQ, terminals PQ, in the diagram above is dash. So they want us to find the total resistance in this network. So now the first clue I want to really give you is that if you want to analyze this, of course, you know that resistors have two arrangements. Either they are arranged connected in a series or they are connected in what parallel. So you need to remember that your resistors, this actually means series connection, and if this is R1, this is R2, definitely because it's series connection, the total resistor or resistance here is going to be R1 plus R2. So when it is in series, okay, you only add them up if they are in series. That is, they are connected, end to end like that. But if it's in parallel, you will see arrangement that will show that different currents actually flow through them. So here, if you look at it, any current that flow here, the same current that flow here through this resistor will flow through this resistor. That's why we say that in series arrangements, the same current will flow, but they are going to have different, potential difference. Okay, this will be your V1 and this will be your what? Your V2. Okay, this is just the summary. Of course, we'll still do some questions that will really reveal this. But all I just need you to realize here is that just remember your series arrangement and parallel arrangement. Series arrangement you had, in parallel arrangements, okay, we say that what R total will be what? It's going to be 1 over R total equals to 1 over R1 plus 1 over R2. And then we can say 1 over R total. I just want to show you a shortcut. That's why I'm actually doing this. So your SCM will be R1, R2, okay? And that would be what? R2 plus R1 if you find your what? SCM here. And then we have 1 over R total equals R1 plus R2 over R1, R2. So if reciprocal of this is equals to this, therefore R total is going to be R1, R2 over R1 plus R2. So you can always use this formula for your parallel arrangements, okay? If two resistors are in parallel. So if you want to find the R total, you can easily remember this formula rather than just doing 1 over this, 1 over that. Just say R1 times R2 over R1 plus R2, because I'm going to use that in this what question. So it's very good because as a Jambite, you need to learn how to save time. So now I'm cleaning this now so that we can analyze the diagram. So if you look at this diagram, let's analyze it first. You will see that this is connected to this straight and this connected to this straight. So it means that what this is in series with this and is also in series with this. So these three resistors here, they are in series arrangements. You can stretch it. You can use your eyes to stretch it. If you stretch this, you will see that what there's no branching at all for the current. Okay, if you stretch these three resistors like this, if you stretch them straight, you will see that it's actually 2 ohms, 2 ohms. You can see that that's a series arrangement. So we'll first find that one. We say that what R. Okay, let me call that one first R. Okay, let me just use the word first R. That would be 2 ohms plus 2 plus 2. That will give us what? 6 ohms. So this is what this arrangement will give us for the two resistors here in series. So the diagram will now become something like this. If I'm to redraw this diagram, it's going to reduce to something like this. I've not touched all these parts. I've not really touched all these parts. They are still there. Okay. I've not touched all these parts. This is still my P, this is still my Q. It's only these three I've already touched. So these three now, they have become one. Okay, if I'm going to connect their total now, it's going to be like this. That is what 6 ohms, and that's your what 3 ohms. That's your 1 ohm, and this is your what another 1 ohm is here. This is another what 1 ohm. Okay, so that's the network now. It has reduced to something like this now. So another thing is that what I'm analyzing from the back towards the terminal. So this and this, they are in parallel. You can see it's not the same current that flow through this one. If current should flow through this one, when the current get to this junction, the current is going to divide. Part of the current will go here, part will go here. So it's not going to be the same current that will flow through this. So you can always use current to trace if they are in parallel or in series. So since different current will flow through them, current will divide here. So this is what a parallel arrangement. So I'm going to do parallel arrangement of 3 and 6, and that will be R total. Since it's parallel, I've shown you the shortcut. That's R1 R2 over R1 plus R2, and in this case, what is that R1 and R2 is this 3 and 6. So that will be R total there in this place now will be 3 times 6 over 3 plus 6. That will be 18 over 9, and that will give me 2 ohms. So I've gotten another 2 ohms. So the network will reduce again. Okay, I'm just trying to use this one to show you. I'm not saying that in your exam this is how you'll be drawing and everything. Once you understand it, even without writing anything down, it's possible that you have your answer, but you must have practiced, practice and practice on this. So this has reduced now. This network has reduced to something like this now. This is now 1 ohm, 1 ohm. The total of this one is now what is here, which is now 2 ohms. So when you look at the network that we have left, you can see that what this arrangement here is a series arrangement. If current flow through here, the current will pass through here, will pass through here, the same current. So in other words, this is in series with this, in series with this, and now the R total that we have, the total R that we have in this place will now be 1 plus 2, since the series arrangement, plus 1, and that will be what 4 ohms. So the total resistance that I have here will sum up to what 4 ohms. I hope you understand that anyway. So you take it, one after the other. Of course, in subsequent questions, you get better at it. But I just hope that you catch up with this one I just solved. So let's attempt question number 2. Question number 2. Question number 2. Okay. Now, question number 2. The sum of the currents I1 and I2 in the figure below, okay, is, so they want us to find the addition, that's the sum of I1 and I2. So let's look at the circuit very well. This is our I2 here. So this I2 is flowing through a 10 ohms resistor. And this I1, if it's going to flow, it will flow through what? 5 ohms and this 10 ohms. So in other words, these 5 ohms and this 10 ohms, they are in series arrangement. But both of them, they are now in parallel to this what? 10 ohms. And in parallel connection of a resistor. Same voltage, but different current. So I2 will flow through this one, different current from I1 that will flow through this one. But it is the same voltage, that's the same potential difference that will be here, that will be here. And what is that potential difference? That potential difference is what? 12 volts. So that's very simple. So for us to calculate we are going to remember our Ohm's law, and then we want to calculate current. We say current equals to what? Potential difference over R in 10 ohms, in this 10 ohms that is here, okay, that is standing alone. That is a I2. So I2, or let's just say our I2 here will be V. What is our V? That V is what? 12. And what is the resistance? The resistance is what? 10. That will give us 1.2 ampere. So for the I1 will be what? Equals to the voltage that we have, the same voltage, which is 12. But is going to be, the resistance is not going to be the total resistance here, but because this one is in series, okay, series arrangement, that is the what, R total. What is that R total? That R total is I equals to 12, that is 5 plus 10, because they are in series arrangement. So that will give me I1 equals to 12 over 15. Okay, so I can cut this, I can say reduce this to 3 here, that's 3, I mean 4 over 5, and that will give me 0.8 ampere. And that's right, that's 0.8. So now what they ask us to do sum of I1 and I2. That's the question. Find the sum of I1 and I2. Now that I know my I1 is what, 0.8, and my I2 is what, 1.2, and that will give us what, 2.0 ampere. Okay, this is what we are going to have in the question. So this is the solution to the two questions that we have on the board, and this is under electricity. We'll begin to solve more questions in this area. You know, you practice, you lay your hands on it. It's just like a regular stuff that JAMB always bring out almost on a yearly basis. You must have questions under what, electricity. So try to share out this video to other students so that they can benefit from it. I want you to give me thumbs up, like this video, share it out, comment, let me know that you understand. Okay, and if you have not subscribed, please subscribe for more videos I will be uploading. Till next time, you'll be seeing more videos from me. Have a lovely time studying. Bye for now.